Every great technological revolution eventually escapes the laboratory. The steam engine escaped the laboratory and transformed factories. Electricity escaped the laboratory and transformed cities. The internet escaped the laboratory and transformed communication. Artificial intelligence is now escaping the laboratory, and it is beginning to transform something far bigger than software: infrastructure. If you ask most people where the AI revolution is happening, they'll probably point to Silicon Valley. They'll mention ChatGPT, Google Gemini, Claude, Grok, or the brilliant engineers building increasingly powerful models. They're not wrong, but they may be looking in the wrong place. Because while the world is watching software, the real race has quietly moved somewhere else, to power stations, transmission lines, nuclear reactors, hydroelectric dams, electrical substations, and vast data centers that most people will never see. The biggest challenge facing artificial intelligence is no longer making it smarter. It's finding enough energy to keep it running. History has a habit of disguising its biggest transformations. When railways first appeared, people thought they were simply a faster way to travel. Few realized they would reshape trade, cities, and entire economies. When electricity arrived, it was seen as another invention. It eventually became the foundation of modern civilization. Artificial intelligence may be following the same path. Most headlines celebrate the latest chatbot, the newest image generator, the next breakthrough model. Meanwhile, something far more consequential is happening beneath the surface. The physical world is beginning to reorganize itself around intelligence. That may become the defining story of this century. To understand why, we need to abandon one of the most successful illusions of the digital age: the cloud. It sounds almost magical, invisible, weightless, as though intelligence simply floats somewhere in cyberspace. But the cloud isn't a cloud. It is one of the largest industrial systems humanity has ever built. Every question you ask an AI travels through fiber optic cables into enormous facilities filled with thousands of specialized computers. Those computers rely on transformers, substations, cooling systems, backup generators, and electrical grids capable of delivering astonishing amounts of power. Behind every intelligent answer lies an industrial supply chain built from steel, concrete, copper, semiconductors, water, and electricity. Without that physical infrastructure, artificial intelligence simply doesn't exist. That changes the way we should think about AI. For years, the technology industry competed to build faster chips, better algorithms, and more capable software. Those things still matter, but another constraint has quietly overtaken them: energy. Every improvement in AI demands more computing. More computing demands larger data centers. Larger data centers demand more electricity. What was once a software challenge is rapidly becoming an infrastructure challenge. And that changes everything. It also explains a question that has puzzled many people. Why are some of the world's biggest technology companies suddenly investing in nuclear power? Why are they signing electricity agreements that stretch decades into the future? Why are governments rewriting energy policy? These don't look like AI stories, but they may be some of the most important AI stories unfolding anywhere in the world. Because a more intelligent AI is useless if there isn't enough electricity to power it. For decades, Silicon Valley dominated the technology industry because it concentrated talent. The next phase of AI may depend on something much older than talent: geography, reliable electricity, available land, efficient cooling, modern transmission networks, governments willing to build quickly. In other words, the future of artificial intelligence may depend as much on energy engineers as software engineers. And once you see that, the entire AI race begins to look very different. The first phase of the AI revolution was about intelligence. The second phase is about scale. Creating an intelligent model is one challenge. Deploying it to billions of people is another entirely. Think about what happens every time someone asks ChatGPT a question, or searches using Google's AI, or generates an image, or asks an AI assistant to summarize a document. Each request feels almost effortless. It takes only seconds. But somewhere in the world, thousands of processors wake up. Electricity flows. Cooling systems activate. Servers begin calculating. What feels instantaneous to us is the result of an enormous industrial process happening behind the scenes. Now imagine that process repeated billions of times every single day. That is the future artificial intelligence is moving towards. According to projections from the International Energy Agency, electricity demand from data centers is expected to more than double by the end of this decade, driven largely by artificial intelligence. By around 2030, AI and data centers together could consume close to 1,000 terawatt-hours of electricity every year. That is roughly equivalent to the annual electricity consumption of a large industrialized country. An industry that most people cannot even see may soon require as much electricity as an entire nation. And demand is still accelerating. There is another part of the story that receives far less attention: training and inference. Training is how artificial intelligence learns. Engineers feed enormous amounts of information into powerful computers over weeks or even months. It is expensive, energy-intensive, and technically demanding. But surprisingly, that may not become the biggest long-term challenge. Inference may. Inference is simply the process of using AI after it has already been trained. Every prompt, every search, every conversation, every image, every translation, every recommendation. That's inference. One request uses very little energy. Billions of requests create a completely different equation. Imagine building a motorway. Construction is expensive, but once it opens, millions of vehicles use it every day. Eventually, the traffic becomes the real story. Artificial intelligence is beginning to follow the same pattern. Training builds the system. Inference keeps the system alive. As AI becomes embedded in search engines, hospitals, schools, governments, businesses, and smartphones, the continuous demand for inference could become one of the largest sources of computing demand ever created. That changes the economics of artificial intelligence. Not long ago, the defining question was, can we build smarter AI? Today, another question has become just as important. Can we power it? That single question is reshaping investment decisions across the global technology industry. Because an AI model without electricity is no different from a factory without power. The software may be extraordinary, but without energy, it produces nothing. And that's why something remarkable has happened. The conversation has quietly moved away from processors towards power stations, away from algorithms towards electricity grids, away from software companies alone towards utilities, transmission operators, transformer manufacturers, and energy providers. Artificial intelligence has done something few expected. It has brought together industries that rarely shared the same conversation. The digital economy is becoming inseparable from the physical economy. And perhaps the biggest winners of the AI revolution won't all be software companies. Some may be the companies that generate, transmit, and distribute the energy that intelligence now depends on. That raises a much bigger question. If electricity is becoming one of the world's most valuable AI resources, who controls it? Because the answer may determine which countries lead the next technological revolution. That question is already changing the behavior of the world's biggest technology companies. Not because they suddenly want to become electricity companies, but because artificial intelligence has changed what electricity means. For decades, electricity was simply another operating expense. Today, it has become a strategic resource. The companies leading the AI revolution have realized something profound. The next breakthrough may not come from building a smarter model. It may come from securing enough power to run it. That explains why companies traditionally associated with software are now signing long-term energy agreements worth billions of dollars. Why they are investing in renewable energy projects, supporting the development of small modular nuclear reactors, helping restart existing nuclear facilities, and securing dedicated electricity supplies for future AI campuses. A decade ago, those decisions would have seemed completely unrelated to technology. Today, they are becoming central to it. Because intelligence without infrastructure is only potential. Infrastructure is what turns potential into capability. Notice what this means. The companies shaping the future of artificial intelligence are no longer investing only in code. They are investing in power. And when some of the world's most valuable software companies begin treating electricity as a strategic asset, it tells us the rules of the game have changed. This is also changing the map of artificial intelligence. For years, the technology industry revolved around places with the greatest concentration of talent. Silicon Valley became the symbol of that model. But AI is introducing a new geography, one shaped by resources. Countries with abundant hydroelectric power suddenly have an advantage. Countries with reliable nuclear energy have an advantage. Countries capable of expanding their electricity grids quickly have an advantage. Countries with vast natural gas reserves have an advantage. Even colder climates are becoming attractive because lower temperatures reduce the enormous cost of cooling data centers. For the first time in decades, geography is becoming a competitive advantage in the digital economy. That is why governments are paying such close attention. Artificial intelligence is no longer viewed simply as another technology industry. It is becoming part of national industrial strategy, because whoever builds the strongest AI ecosystem is likely to attract investment, high-value manufacturing, scientific research, highly skilled workers, and entirely new industries. In other words, artificial intelligence is becoming a driver of national competitiveness. History has seen this pattern before. The countries that mastered coal gained an advantage during the Industrial Revolution. Those that secured oil shaped much of the 20th century. The 21st century may follow a different path. The defining resource may not be oil. It may be reliable electricity. Not because electricity has become more important than intelligence, but because intelligence has become impossible without electricity. Yet electricity is only one part of an even bigger story. Because there is another resource that artificial intelligence consumes, one that almost nobody talks about: water. Water may be one of the least understood parts of the AI revolution, not because computers consume water directly, but because they generate enormous amounts of heat. Keeping thousands of high-performance processors cool requires sophisticated cooling systems, and many of them depend on vast quantities of water. As AI grows, its demand for water often grows with it. That is forcing companies to rethink where they build data centers, how they cool them, and how they manage increasingly scarce natural resources. Once again, the challenge isn't software. It's infrastructure. This also exposes one of the biggest misconceptions of the digital age. We talk about the cloud as though it exists somewhere above us. It doesn't. The cloud has an address. It occupies land, consumes electricity, requires fiber optic networks, substations, cooling systems, security roads, and continuous maintenance. In many ways, a modern AI data center has more in common with a power station than a software company. Artificial intelligence isn't replacing the physical world. It is making the physical world more important than ever. Once you begin looking at AI through that lens, everything starts to connect. Entire regions are competing to attract the next generation of data centers. Artificial intelligence is no longer transforming just one industry. It is beginning to reshape many of them at the same time. History suggests that every major technological revolution eventually produces new winners and new losers. The AI revolution will be no different. This is Clariform, explaining what matters.